Okay, so as I was saying, so we are talking about Web three, the basics, the core basics of Web three. So in the history of the web, over time we've had different series at different points in time. At the earlier on in web history, we had Web one, which was just information economy, and this is basically just to receive information. And that was when we have our Yahoo, where we had our Internet Explorer. The early days of the internet was basically read only, was basically about information. It was just for us to get the latest information, what is happening, and all. You can only read all of this information, right? So, in come Web 2. At the entrance of Web 2, we have a much more robust technology. That is where we have our Facebook, our Twitter, our Google, YouTube, WordPress, where we can not only read this information, we are also able to write about this information. Like each person now has ability not just to read, but also to write about this information. And then we have Web three, and in Web three, it is the token economy, and we have three phases: we can read, we can write, and we can also execute. We can execute in the sense that we can allow smart contracts, we can give certain instructions to a smart contract and make it run autonomous of itself, just like we have AI agents in recent days. That is same way that we have the Web three. So at the advent of Web three, we had the blockchain technology, where we are able to like have a whole lot of things that we have right now. That is Bitcoin, Ethereum, Solana, all of these things that we have. We're able to build them based off this token economy, right? And with that, we're able to have a whole lot of decentralized application. It's opened the door to a whole lot of decentralization, like across board. Now we have web apps, we have we have web I mean we have MetaMask, all our wallet applications, all our decentralized application. And that's basically what the advent of what Web3 has brought to us. That's what Web3 has brought to us, basically. So so the next thing I'll be going into now would be explorers. So now with Web three, with every of these blockchain technologies, that is um, Ethereum, BTC, Solana, and every of the other networks that we have, there is something called explorers. Before I get to explorer, so blockchain is basically a public ledger, and by public ledger I mean that you are able to you are able to like read, you are able to see what every other person is doing online. For example, let me give an example of traditional finance. So in traditional finance, in our banking system, when you make payments, when you are trying to send money from someone to another person, you have access to your bank account, you press the person's account number, and you send it. I know if I send money. I don't know if you try to process money. Even though I know your bank account, or I know your bank wallet address, or whatever it is, I cannot know the details of what you are sending or what you are not sending. The traditional banking system works in an enclosed system. It is centralized and enclosed. Am I having a message? Yes, I'm recording it. I'm currently recording it. You've not missed anything. We just got started. So, tradition. I was talking about traditional finance, like our banking system. It works in an enclosed. It's an enclosed system whereby it's only who is sending and who is receiving that gets to know and understand what they are doing, and maybe the centralized body that is guiding it, that is the banking officials or the banking system itself, that gets to know that client A is sending money to client B. But this is totally different in decentralized world, or in Web3 world. In Web3 world, with a wallet address, or let me say bank address. Now let me use bank address since I'm using traditional finance. With your bank address, I can literally see all of the transactions that you've been able to carry out from inception. That is all the transactions you've carried out from the very first day, like from your very first transaction to your current transaction. If I want to download it and have it and see all of those transactions, the same way each individual can download a bank statement, that is the same way a public ledger works in on the blockchain system. So with a public ledger, with your address, with your wallet address, I can see what you are sending and to whom you are sending it to. That is, I might not know this person, that oh, this is the actual person you are sending it to, but I get to see the wallet address of the person you are sending it to. So I'm able to see what you are sending. I'm able to see when you sent it. I'm able to see the costs and every details that entails whatever you are sending from one party to the other. So that is what classifies the Web3 whatever as, that's what classified blockchain as a public ledger. And before talking about that, blockchain, the blockchain technology has three profound properties. I don't know if if they've talked about this in the former class. So it has three profound properties, and the first one is, let me just go to this slide. Let me just go to this slide so that I will be able to follow the proper sequence. I'm sorry. Few minutes, please. Okay, yeah. So the blockchain technology has has three properties, and the first one is decentralization. The second one is immutability, and the third one is transparency. So I'm going to explain each of it. I think I've explained one already. I've explained decentralized part of it. So but I'll start again. So by blockchain being decentralized, um, you can't see anything. Can you see? Can you see? Is my screen visible? Is my screen visible? Is my screen visible, please?
Yes, it's
Yeah,
visible.
Okay. I just want to know. I just want to confirm if my screen is visible. Okay, yeah, it is visible. I can see it already. Okay. So blockchain fundamentals, core blockchain properties is that it is decentralized, it is immutable, and it's transparent. So the first one is the decentralization of blockchain. Just like I explained, in traditional bank, there is a central entity that controls what moves here and there. Like when I need to move money from bank A to bank B, there's more like, although it has been more like agent controlled, such that when I send money, they send it to the other account, but there is always a central body governing it, and those central body can decide to block my account or block the account of my recipients. They can decide to do anything they like with that because it is a centralized body, and there is control over that technology, like over the banking system. There is a control, but that is not so in blockchain technology. There is no single entity that can control. The moment I have BTC, Ethereum, Solana, or whatever I want to send, the moment I have it in my wallet, I can send it to anybody at any point in time without anybody stopping me or saying, why are you sending this amount, or this amount you are sending is too much. There is no regulation to how much or how less you can send. So far you know the person you want to send it to, you can literally do transaction at any point in time, and that is the beauty of the blockchain technology. It is decentralized, no single entity control over the network. Then the second one is immutability. By immutability, it means that whatever transaction you've done, it is done. Like you cannot cancel it, you cannot alter it, you cannot reverse or say for example you try to send money to an account now, and maybe in some ways you can write a letter to CBN or whatever to reverse the money back. But in blockchain system, the moment you press send, it has gone already, and there is already a record of it being sent. And the funny thing about the blockchain is that even the moment you send, let's say there is a high gas fee and the transaction ends up not going through, but there is a transaction hash, there is already a record on the blockchain that you made the transaction, even though the transaction did not go through. So with blockchain, it is totally immutable, such that you cannot alter whatever transaction you've done. The moment you press send, the moment you try to carry out a transaction, it is already permanent and written on the public ledger. Then the third thing now that is the third property and fundamental of the blockchain is that all transactions, just like I explained the other time, all transactions are publicly visible. They are very, very visible. You can see what person A is trying to send to person B. Like there is no stopgap, there is no hidden details about what you are sending or what you are not sending. And that is basically what we'll be talking about basically with explorers. So each of these blockchain networks or blockchain technologies, they have their own explorer. And by the way, when I make mention of technology, I mean when I make mention of networks or different networks in blockchain now, just count it the same way we have MTN, Glo, Etisalat, and the likes. We have different networks that carries out different things in the blockchain system. And why do we have? So you might want to ask, why do we have BTC network, we have Ethereum network, we have Solana? Why do we have a whole lot of different blockchains? What exactly, like why exactly do we have different blockchains? And the reason is because so in a blockchain network, in a blockchain network, there are trilemmas that a particular blockchain tries to solve. The first one is its speed, scalability, the scalability of the system, how fast the system can carry out transactions, the scalability. The second one is security, the security of the system. So this is in order to monitor your transaction, to make sure that whatever transaction you are sending is is whatever transaction you are carrying out is secured. That is, there is no issue with whatever transaction you are carrying out. And the third one is decentralization. So we have security, we have scalability, and we have decentralization. Those are like the three trilemmas that each blockchain is trying to solve. So over time, of course the first and most populous and common blockchain technology we have, is the crypto network. But over time we found out that at a particular point, blockchain, Bitcoin network rather, I meant to say Bitcoin network. Bitcoin network was the first crypto, blockchain technology that was formed. And at a point in time, they found out that okay, Bitcoin was decentralized. It has good decentralized system, but there is a problem with its scalability, and that was what gave birth to a whole lot of layer one protocols that we have. That was what gave birth to Ethereum. That was what gave birth to Solana and a whole lot of other blockchain networks or technologies that we have over time. And you would also ask that, okay, when we already have Ethereum, why do we have layer twos? Why do we have layer two like Polygon? Why do we have layer two like Scroll? Why do we have layer two like which other layer two system do we have now? I think Linear is a layer two. Why do we have a whole lot of all this layer two? The reason we have this layer two is also based on this trilemma that we have. They found out that okay, security is good, Ethereum is decentralized, but there is problem with scalability. So we find out that maybe when there we have a whole lot of transaction going on Ethereum network, we have high gas fee, like we have high transaction fee, and that is because and that's because of the way Ethereum network is built. So in order to solve that problem, that was what gave birth to layer two. And with layer two, they are able to they are able to, how do I say this now? So let's say we have 100% and we need to have this 100% distributed, evenly distributed among security, decentralization, and scalability. They are able to allow one be higher than the other. So for a whole lot of layer two, they take they are very very conscious of the scalability because they want more easy access, they want lesser gas fee, they want transaction to go as fast and easy as possible compared to on layer one when we have high transaction. So they are able to make sure that we have high scalability, but at the same time there is a problem with security and decentralization. They relinquish security and decentralization just to be able to have better scalability. That is like one way of trying to solve that trilemma that we have, and that was what gave birth to all of these different networks. I'm just trying to explain why we have these different networks. So I already said the other time that just like we have MTN, we have Glo, we have all of these networks, for example, now that is the same way we have Solana, we have Binance Smart Chain, we have Base Chain, Polygon, Linear, and a whole lot of all of these things. And since all of these are independent of each other, that is, they have their own different networks, then we now have what we call an explorer. And the work of an explorer is just like I explained the other time when I said, blockchain is a public ledger. The work of an explorer is more like the work of a register, it's more like the work of a ledger, where you can see everything happening, everything going on that chain, on that particular network or that particular blockchain. So the first one that I'll be talking about is Etherscan. So Etherscan is an explorer for Ethereum, and on Etherscan, on this explorer, you are able to see every of the details that you need or that you need to understand or that is necessary on Ethereum. So right here we have the Ethereum price. Here we have the gas fee, and this is the gas fee. This is the current gas fee to process a transaction right now. You need like 4.5 GUI to process a transaction. So we have blocks. So blocks are so okay. So blockchain. Maybe I didn't explain this too when I was explaining blockchain. Blockchain is literally blocks of chain. It's like a connection of different blocks. That is, one block lead to another. So at the invention of Bitcoin, let me use Bitcoin for example. There's a Genesis block, and basically what a block is a block is just several transactions bundled up together into one. So block are just groups of transactions. Like when we have a whole lot of transactions bundled up together into one on the blockchain. And the way it works on blockchain technology is that one block leads to another. Like there is a link from one block to another. And that is what we have here. So we have miners that process blocks. So blocks, to create a block, you literally have to do, I don't want to go into like in-depth details. You literally have to solve some mathematical, some computational mathematical problems in order to be able to create a particular block. So we have miners. So what happened is that for a transaction to go through on a blockchain network, there had to be different people that process this transaction. What I mean by process this transaction is that there have to be different people that signs and approve this transaction, that okay, this transaction is verified. And in order to have that, we have different mining system across the whole world. Like they are spread abroad across different parts of the world. And what these miners or what mining does is that they are able to process blockchain. They are able to process blocks, all these blocks in blockchain technology. I'm trying not to. I'm trying to make it as simple as possible. So so these blocks, those are what we have here. So we have latest blocks. The latest block we have is processed by this particular miner, and this is the current blocks, and this is the number of transactions in this block. In this particular single block, we have 245 transactions that are bundled together, and we have all of these records, like, as much as possible. If you keep going down, you keep seeing all the blocks that have been processed throughout today. These are different blocks that have been processed throughout today. And the first block that is processed on a particular blockchain network is called the Genesis block. So the first block, say the first block on Ethereum chain is the Genesis block, and that block leads to the next block, connected to the next block, connected to the next block subsequently, and that is how we have different blocks over time. So yeah, so at this section we have blocks that have been generated, like blocks of transactions that have been processed, and then we have latest transactions. This is the latest transaction over time. Then we have the Ethereum price, Ether price. So Ether is the native coin of Ethereum blockchain network. So we are this is enterprise, which is $3,000 currently. The equivalent of this in BTC is 0.3 BTC. Then we have transaction. These are transactions that are processed. We have TPS. TPS is transaction per second. This is the transaction that is processed per each second. So Ethereum chain currently is processing 15.7 transactions per second, and this is the median gas fee. Like the gas fee that we've had in, like, the average gas fee that we have over time. Like currently, this is what the average gas fee is. So to process a transaction on Ethereum blockchain, the average transaction will cost just the same way when you send money from Access Bank to, say, UBA now, and they probably charge you 10 naira, 50 naira, or whatever, what have you. That is the same way with this transaction fee that we have here. So that's the same way we have this transaction fee. So this is the number of transactions that have been processed in the last 14 days. Over the last couple of weeks, that's 2 weeks. These are the number of transactions that have been processed on Ethereum blockchain. So for market cap, in order to calculate the market cap of a coin, they need to multiply the current price times the total supply. Yes, yes. Current price times the total supply of that particular coin. No, times circulating supply, rather, times the circulating supply of that particular coin. That is that's how we come about market capitalization of a coin. So let's now dive in depth into how each of these transactions, how they work. So with each transaction, there's a transaction hash. Just like if you open your bank app now, let me try to open my bank app. If I open my bank app now and I go to probably my transaction history and I select any of my transaction, I'm able to see all of my transaction details. And if you check your bank app, I'm using OPay to check this right now, you would see something called transaction number. So say if I have an issue rather with my transaction, what I need to give to my bank agent or whoever it is the transaction number. And with the transaction number, they are able to know who I'm sending. Who is sending the money? Who am I sending it to? How much am I sending? And that is the same way it works in on on blockchain technology. So we have transaction hash. So with transaction hash, you have a full overview of all the transactions that of the transaction, of the actual transaction you are carrying out. So the moment you carry out a transaction on blockchain, on any blockchain network now, whether Ethereum, whether Solana, we are still going to check out other sorry, we are going to check out other explorers just to see how they look. But using Ethereum as the base explanation now, the moment you have the transaction hash, you are able to see all of the details of that transaction. So talking of public ledger now, with this I can just pick out any transaction hash, and I'm able to see what happened, what the actual details or what exactly happened in, I mean, what actual transaction happened. So with this, we have transaction hash. This is always a transaction hash, and with this transaction, if I copy this transaction, if I'm using any Ethereum Explorer, I'll be able to see the details of this transaction at any point in time. So this is the status of this transaction. This transaction was successful. If it was not successful, it will also show that it was not successful, even though the record has been written on the blockchain. And the next thing is the block. So this is the actual block that this particular transaction was carried out. It was carried out on this block height. They call this number block height. This is the block height that this transaction was carried out. The timestamp, this transaction was carried out 7 minutes ago, and it was carried out today. And this is the time it was carried out. That is this is 8:54, because the UTC is UTC. We use UTC plus one. So the transaction action, what actually happened? What was the transaction details? The transaction details is that this user, there's a transaction of 30 so, that is, I mean 30 so coin. This person sent um, um coin to this particular address. So this particular address received 30 and it was sent from this wallet. This wallet was the one that sent it to this wallet. So if we check this wallet now, for example, we are going to see the record of from this to this. Yes, if we check this wallet, this address, we should see 30 Yeah, this was the 30 This was the 30 value that was sent from wallet A to wallet B. So we can, with the Explorer, you can track out the exact details of what is happening. So let me go back again. With this transaction hash, I'm able to see all of the details, everything that went down, everything that happened in this transaction. I'm able to see the action that was carried out, which was a transaction of 30 that was sent from this wallet to this wallet. So with the blockchain, there is no lies. You cannot lie. Like Damilare would say that some of the influencers might decide to lie and say that they receive airdrop, or they receive amounts. If you have a transaction hash, or you're able to track or check out the blockchain details, you can easily see who is lying and who is saying the truth, because the record will always be there. It does not clear up. You cannot manipulate it. Whatever is written there, it is what the details is. So for this transaction, we're able to see the transaction that was carried out, that this amount was sent from this wallet to this wallet. And this is the transaction fee, 0.09. That's the transaction fee. If you need more details, you're able to see a whole lot of other technical details. These are more technical details that are useful on the technical side. That are useful on the technical side. So let's check out another. So with this, you can check out as much as possible transaction. Every of the transactions that happen over, like, if we're able to go to the last page. Okay, let me see. The last page. Okay, the last page as of today is 8 hours ago. So these are transactions that happened 8 hours ago. Um, this is a batch claim from. Okay, let me select this. This is a transfer. If I select this now, you're able to see transaction hash under this block art. You're able to see that there's a transfer of 6,000 USDT to Binance deposit. That is, this person deposited 6,000 USDT to his Binance account. They've tagged this account. They've been able to recognize this as a Binance wallet, and that's why it is tagged as a Binance deposit. And it was sent from this wallet, and they interacted with this smart contract. So, smart contracts are basically self-executing codes, just like we have AI agents, where you give a particular set of instruction. You have a particular set of instructions. Say, okay, um, the way a robot works, where A robot is literally something you give an instruction that can carry it out autonomously. That is basically what a robot is, and that is basically more like what a smart contract does. So with smart contracts, you have certain codes or certain instructions that are already written, that are self-executing, and that is what smart contracts, that is what they are. So so this particular token, this is its smart contract. That is, this is the contract of this particular token. So if I'm sending USDC, this is the contract I'm interacting with. You can see interacted with this particular smart contract. If I select this, you'll see the details of this token, which is USDC on Ethereum. You see the details of USDC on Ethereum. So um, so there's a transfer from this wallet to Binance Deposit, and this was the gas fee. This was the time it was carried out. You can see all of the details. This was done 8 hours ago, but we can still find the details. If I'm able to find out, say, a transaction hash of a transaction that probably happened maybe in 2015, for example, now I would also be able to see all of these details. I'll be able to see all of the details, all of the transaction that happened over time on that particular, on that particular chain. So another thing you can also check out, you can check out transactions, you can check out pending transactions, probably transactions that are still pending. You can check out contract internal transactions. Those are transactions between two different smart contracts. You can check out a whole lot of different details. You can check out a whole lot of different details in this in all of these all of these things. You can check out a whole lot of different details in all of this transaction, whatever, in all of this explorer. So the explorer is an open ledger for you to see all of the details, all of the transactions, all of the things, all of the events that happened in on the blockchain. So you can check, you can use this to search for an address, you can use this to search for a transaction hash, you can use this to search for a block height. Let's say we are searching for a particular block height. If I copy this block height now, for example, maybe I post this block height, I think you should be able to recognize this as a block, and I'll be able to see all of the details of all the bundle transactions that happened in that block. Let's see. Okay, yeah, it has recognized it as a block, and this is the details of the block: 164 transactions, 59 contracts internal transactions, 16 withdrawals, the gas fee used, and all of the details. These are all the details of transactions, the bundle transactions. So if I want to check a transaction that happened in that block, I can click it and I'm able to see all of the transactions that happened on that particular block, on that particular block. And so if you check this method side, you would see different information about the kind of transaction that went down. This is a transfer, this is a transfer, this is a smart contract approval. Say, for example, if you are trying to use a decentralized application now, for example, sometimes on your MetaMask, it will ask for a particular approval. Maybe sometimes it asks for first approval before it carries out the actual transaction. So this is an approval. This is set approval for all. So it basically writes out, this is batch claim. Maybe an airdrop was claimed and it was claimed in batch. This is black. So it literally lists out the actual transaction or the type of transaction that you are trying to carry out on. This is stake. It means this particular person staked their coin. This particular person staked their coin. You can see call function stake. This particular person staked their coin. I guess they staked on Coinbase, something. So you can see the type of transaction and you're able to, so from your Explorer, you're able to know what, which and what the particular transaction is all about. And so this is Ethereum Etherscan. Etherscan is the most popular Ethereum explorer. There are other explorer. I think there was Eth Explore at a point in time. Let me see if it's still working. Yes, Eth Explore is also an explorer on Ethereum chain. We have several explorers, like a whole lot of explorers that do different jobs. Some of them they have different functionalities, maybe some functionalities that the other one does not have that this particular one has. So Earth Explorer used to be a very, very popular explorer during the early Ethereum bubble days, during 2017 thereabouts. It used to be a very, very popular whatever. And I think they have performance. I guess this should be performance of Ethereum blockchain. You can see we did not have these particular details on Etherscan, but we have these details: transaction, token transfer, unique addresses, active addresses. This is active addresses or unique address over time. All of the details over time. So as at today, today is January 25. Um, Let me see. As at yesterday, 24, we have oh, I'm trying to see. Okay. As at January 17, January 17 had 1.2 million transaction, 1.3 million token transfers, 303 unique addresses, active ad, I mean 300 303 active unique addresses on Ethereum chain and 627K active addresses. So maybe active addresses are people that carry out one or two transactions on the chain on that particular day or as at that particular time. Okay, is that a question? You can't see anything. Ah, am I how many of us
I
cannot
guess
see
it's,
anything?
I guess it's from her. I can see it
Okay,
clearly.
you can see clearly. Okay, okay, good. So this is this is one of the explorers on Ethereum chain. So I've been talking about Ethereum. You might be wondering, okay, does Bitcoin has its own explorer? Yes, BTC has an explorer, but BTC transaction explorer is not because of the way Bitcoin transaction is. It is not as widely used like Ethereum. But the core function of an explorer basically is just to be able to check out the details of whatever transaction you are carrying out. Is this blocked in Nigeria? I think this particular one is blocked in Nigeria. Let me try another one. So the thing with Explorer is that so I can copy a transaction hash and check it on um, Earth Explorer or check it on Etherscan. I don't particularly need to check that, okay, because I'm copying this transaction on Earth Explorer, I can only check it on Earth Explorer. No. So far it's a transaction hash of that network. The only thing you need to look out for is that particular network's explorer. Then you'll be able to see the details in full. This is a Bitcoin explorer, and these are, of course, in Bitcoin too. We have hash, we have block height, block size. This is the size in bytes of the whole transaction that happened. This is the transactions, total transactions that happen in this particular block. Um, this is the block reward. Block reward is the reward that is given to miners per each block they mine. So 3.125 block reward will be sent, or I don't know how it is, probably distributed among the miners that were able to complete this mining details. So this is the minutes of this transaction. This transaction happened 13 minutes ago. So this is a typical Bitcoin transaction. So you're able to see all of the details. But in Bitcoin case, for each transaction hash, it sums up different transaction into one. Okay, what I mean by that is, on Ethereum Explorer the other time, when I was showing the blocks, we're able to see different transactions that were happening in a block. So that is the same way Bitcoin processes transactions. Bitcoin processes transactions in batches. So the moment we have one batch of transaction, it takes all of those, it takes a single sorry, so it takes a single hash and it bundles up that transaction into one. And so in that particular hash that we checked the other time, this is this particular block hash, these are all the transactions that are carried out. We can check each transaction hash for each individual transaction. So we can check the details of this particular transaction. It was sent from this person, from this wallet to this wallet, and this is the fee this is the value that was transacted, and this is the fee. So those are like the details of Bitcoin transactions that was carried out. So another popular one, let's check Solana. For Solana, the most popular Solana scan is Solscan. So scan, also the same way, all of the similar explanations that we had for Ethereum is something that we have here too. So this is the circulating supply. Okay, so what I mean by, so let me quickly explain that too. So when a coin is created on the blockchain, it has, when the code is written, it has a total supply in the sense that this is the total amount of this coin that is available. I think the total supply for Bitcoin is 21, is it 21 million now? I think 21 million Bitcoin total supply. I think it's 21 million. Yes, 21 million. So 21 million is the total supply of Bitcoin. That is, there can only be 21 million Bitcoin only, nothing more, nothing less. So for tokens that are non-mintable, that is, they cannot mint new ones. The same, so the way we have our naira currency, for example, is mintable because they can decide to mint more naira, and then we have more naira in circulation. But for Bitcoin, it has been written from the inception that there will only be 21 million Bitcoin, and 21 million Bitcoin only that will be available. So, and that has been why we've had increase in the value of Bitcoin over time, because of the scarcity of its supply. I guess we'll get to talk about this, or maybe anyone that will probably take us around the economics around crypto or blockchain will probably touch on this. So there are 21 million blockchain. That's the total supply. So I was just trying to use that to explain circulating supply, market cap, and the likes. So anytime a coin is created, there's always a total supply of that particular coin. Maybe for some of us, we are familiar with pump fund coin. I think pump fund coins, they have 1 billion total supply that is set for them. So you cannot have more than 1 billion supply of this coin. So after the total supply, some token can decide not to release the full supply into circulation. That is, say we have 20, for example now, say Bitcoin we have 21 million, the particular owner can decide that, okay, I don't want this total supply to be out fully. Maybe I want just 25% of it to be totally out. And the 25% that is totally out is what we call the circulating supply. That is, that is the amount that is available in circulation, in public domain, that is available in public domain. So people can only transact or make use of the 25% that is available in circulation. They can now decide to have maybe a vesting period, that is a release of that token. Maybe the remaining, so say we have this token that is 21 million, and 25% of it is in circulation. So it means we have 75% that is not in circulation. We can decide that for this remaining 75%, we can decide that we want to release them into circulation bit by bit. So we can decide that we want to create a 3-year vesting. That is, we are not going to release another percent of the supply into circulation until the next 3 years or the next 3 months. In, so let me use an example. Trump coin, for those of us that heard about it, Trump coin had a particular wallet was holding 80%, and the 80% is going to be in circulation. They will start releasing it into circulation after 3 months, like the next 3 months. So basically, that is how circulating supply works. You have a total supply, you have a certain amount that is available in circulation. You can see here now we have 82% of Solana is already in circulation. This is the 17% of it is not in circulation yet. That is, I guess they will release it over time. That is left to them. So we also have block height. This is the current block height. Block height is basically the height of the block. You know, I said that in blockchain it is block after block. It's more like you are building a block. So this is the current block height that we have on Solana right now, and this is the total um, transaction per seconds. So current transaction per seconds is at the rate of 4,000 this per seconds. This is the total stake. That is the amount that people have staked. Staking is when you probably try to say you are locking up your money for a particular period of time. Yeah, so let me just explain it as that. So we have transactions in Solana. Transactions in Solana can be a little bit confusing sometimes because the way transaction happens or transaction logs and transaction explanation in Solana is totally different from Ethereum. For Ethereum, it's more like straightforward. You have a smart contract, you have a wallet that sends from one wallet to another. But in the case of Solana, at every point in time you want to receive a token or you want to buy a coin or the other, they open a Solana account for you temporarily so that you'll be able to receive the account and a whole lot of other jargon that happened under the net. But I'm not here for that in this class. So for Solana, in Ethereum we had transaction hash. In Solana we had, it's also a transaction hash, but they call it signature. So if you copy this transaction hash, for example, now if you copy it on any Solana explorer, you'll be able to see the details of this particular same transaction. So this is the block height, this is the time this transaction was carried out, it was successful. The signer is the person that is carrying out the transaction. Yes, the signer is the person that is carrying out the transaction. So there is a withdrawal. There's a withdrawal funds on Phoenix. I don't know what Phoenix is. So I guess the withdrawal was carried out here and it was sent to this wallet. This is the transaction fee. This is the program that was interacted with. Like I said, Solana at the point of carrying out a transaction on Solana, it has a whole lot of details. If I open this to see all of, you see a whole lot of details that was carried out. Don't let all of these details scares you, but it is what it is on Solana. Solana transaction can be a little bit funny. So another thing that can help you in understanding transaction in Solana is transaction map. So a transaction map basically just shows a typical visualization of how the transaction happens. So this is the owner, and then this is I guess the receiver. I guess this amount was staked on Jito, whatever, whatever. But this is a transaction on Solana. So if you copy this now, if I copy this transaction hash, like I said, we have different explorer. So let me use another explorer, Solana FM, just for you to know that you can copy a transaction hash from one explorer to another. A transaction hash is not limited to a particular explorer. So I'm waiting for this to load. So while we wait for that to load, so this is all of the different transactions that is happening over time on Solana transactions. So transfer, flash fill, transfer, just like we see also with Ethereum, you can see the instruction or the details of all of these transactions. You can click here to filter. Maybe the only record you want to see is buy. You only want to see the records of buys. So it's going to filter it out and you are able to see the different buy that happened over time. And this is the value of the buy. This is the value. This is the gas fee and this is the program they interacted with. For this buy, it shows that they are interacting with pump fund or a pump fund token, as the case may be. So this is how the ledger looks like. Is this open? Yes. So um this is another explorer on Solana, and you can see the different details. So like I said, if I copy that transaction hash, for example, now I'm going to see the same record, what I saw in SoulScan. I'm going to see something similar that will show all of the details of the transaction that happened. Here you can see all of the details of the transactions, the signer, the program that was interacted with, the fee payer, the transaction fee. Like I said, detailing transaction details on Solana is can be very very funny. If you check in depth, there might be close to like six different wallets that that are involved in a single transaction on Solana. So it can be very very tricky sometimes, but this is the work of an explorer. And with the explorer, you can check out, you can see as much as possible details that you want to see, as much as possible details that you want to see, so far you know what you are looking for or what you are finding on the Solana explorer. So yeah, so that is basically how explorer works across different chains. We can keep checking different chains, and we would see the same thing over and over and over again that happens on chain. Let me see, is there anything I've not? Okay, I think I've explained typically almost everything. We know what a wallet is. A wallet is more like your bank account. That is where you receive your that's where you receive your tokens or whatever it is, whether USDT, whether NFT or tokens. That's where you receive them. I've talked about smart contracts. Minting is literally when you create something new, just like when you mint a new note, for example. Now, so say when you mint a new coin, they call it minting. So that is basically what minting is. When you are creating a new token or you're creating an NFT. That's basically what minting is. I've talked about gas. Gas is the cost of performing a transaction, just like in banking details, where you have transaction fee in processing a transaction. So yeah. So is this not base? Okay, base.org. Any question? If you have question, please. Question, question. Anyone with question? Or is there anything I explained that looks a bit I'm not getting this? I'm waiting for question, please. So in the absence of no question, so what I want us to do is I want us to go through all of these explorers ourselves and just play around it, check out. Yes, I will try to send the recording. Yes, I'm hoping. Of course, I think it should record, so I'll send it across when I process it into MP4, because it's going to be in a raw format. So I'll try to process it in MP4 and send it across. So try to check out all of the different explorers. Check Ethereum Explorer, Base Explorer, Polygon Explorer, Linear Explorer, and just check out the different things that you can find out about the different explorers. Just check them out. If you have a wallet, maybe you've used a wallet before, you can check out transactions that you've carried out on that wallet or list of explorers. There's Zetascan. You can just search. There's Zetascan, there's SoulScan. Basically, a whole lot of explorers use whatever scan. So base scan, there is base scan. This is base scan. There is Binance Match, BNB scan, BSC scan rather. BSC scan. There's BSC scan. Just search for whatever network you want to search for. Just put Explorer in front of it. You would see you would see the details. Okay, I think another thing I did not explain is that with Explorers too, you can see um people holding the tokens. Yes, so let me just search for Floki for example now. So this is Floki coin. So on Explorers, you're also able to get details of every token. So we're able to see, okay, these are the numbers of holders, these are this is the maximum supply of this coin, this is the current price, this is the smart contract address, this is the on-chain market cap, this is circulating supply, these are all the transactions that's happened in relation to this particular coin. So you can check holders and see the details of how much each person is holding. So this is this wallet, this is how much is holding, Binance wallet, um, a whole lot of times in all of these tokens, like popular tokens, the core highest owners are always exchanges because people transact with them and all of that. So you're able to see how much each person is owning of that particular coin. And you can decide to download the page too. There's a place to download this into CSV. Maybe you would need it in a more relatable format in your Excel formats. Yeah. So you can download the CSV and be able to see, sorry, and be able to see all of the details of that particular coin. So there are a whole lot of different, this is the code that was written to create the particular um, smart contract. So there are a whole lot of Explorer. I just searched for, is a block the same as, I just explained what a block is now. So block is just the block in blockchain. So what do I mean? I explained it the other time that blockchain is just a chain of blocks. It's a chain of blocks. Say for example, when you are building your house, you put block over the other, like you arrange block over the other. That is simply how um okay, on YouTube channel. Okay, I think they will do that. So I was explaining blockchain the same way we have blocks arranged over the other. You have this block on this block on that block. That's the same way blockchain works. So you have different chains of blocks. They call it chains, literally. And blocks, like I explained the other time, are just bundle of transactions in one. So a single transaction connected to another transaction on top of the previous one, like that, on top of each other. So it's a chain of transactions. It's a chain of blocks of transaction. That's basically what blockchain is. So any other question? 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 So in the absence of none, over to you, Gloria. Gloria, are you here?
All right, thank you so much, Oladayo. Thank you. It was very um, great explanation, and I hope we understood what we thought today. So next week, we're going to be having the class, same time but not same place. We're going to have our class on Microsoft Team. So please get ready for the class next week. I will urge you to go through the materials that were sent. And if you haven't seen the materials, um, kindly check the material group chats. I'll repost the materials so you can go through them and you can also familiarize yourself with them. All right. So I think that's it from me. No questions? All right. No questions. Thank you guys so, so, so much. Thank you so much,